A breathtaking cosmic event is currently captivating astronomers and stargazers alike across the globe. Betelgeuse, the magnificent red supergiant located on the shoulder of the constellation Orion, is undergoing a profound transformation that is altering its appearance and behavior in extraordinary ways. This transformation has resulted in a dramatic increase in its luminosity, far surpassing its typical brightness by an astonishing 50%. At the beginning of this year, Betelgeuse was known as the 10th brightest star in our night sky. However, this unforeseen surge in brightness has elevated it to the 7th position among the most luminous stars visible from Earth. Betelgeuse is a massive star nearing the end of its stellar life, and its sheer size is staggering. If Betelgeuse were placed at the center of our solar system, its outer boundary would extend all the way out to the orbit of Jupiter. Such a vast star will eventually reach the end of its life cycle and undergo a dramatic collapse, leading to a supernova explosion. This event will be a cataclysmic display, potentially resulting in the formation of either a neutron star or a black hole. The anticipation surrounding Betelgeuse's future supernova is immense because it promises to be an extraordinary and historic event. Given that Betelgeuse is approximately 650 light-years away from Earth, we are ideally positioned to witness this cosmic spectacle firsthand. When Betelgeuse finally explodes as a supernova, the event will be an awe-inspiring display of light. Initially, an intense burst of neutrinos will stream across the Earth, detectable by observatories around the world. Following this, as high-energy photons escape from the expanding debris cloud, Betelgeuse will increase in brightness rapidly over the course of a week, potentially shining up to 100,000 times brighter than it does normally. Depending on the power of the explosion, this celestial beacon could rival the brilliance of a full moon and might even be visible during daylight hours, casting distinct shadows at night. This spectacular event will persist for an extended period, providing astronomers with a rare and unparalleled opportunity for detailed observations and potentially groundbreaking discoveries. Despite historical associations of supernovae with ill omens, we can be reassured by our considerable distance from the expected explosion. To fully appreciate the current situation with Betelgeuse, it is crucial to revisit the end of 2019 when unusual phenomena began to emerge. During this period, Betelgeuse started exhibiting significant dimming, a change that was noticeable even to the naked eye. Observations made using the Very Large Telescope revealed that while Betelgeuse appeared roughly symmetrical in the optical spectrum, its photospheric layers showed signs of considerable disturbance. The photosphere is the outer layer of a star from which light is emitted, and in Betelgeuse's case, it exhibited an expansion that made the star appear as though it was swelling when viewed from Earth. This expansion continued at a steady rate of approximately 8 kilometers per second for most of the year, but by mid-November 2019, the outward velocity began to decrease. By that time, the flow of material from Betelgeuse had stopped, prompting astronomers to capture new optical images of the star. These images revealed two surprising irregularities: a darkened region in the star's southern hemisphere, contrasting sharply with earlier images, and a decrease in the star's surface temperature by approximately 80 Kelvin. Between January 27 and February 13, 2020, Betelgeuse's brightness reached an unprecedented low, about a year after the cessation of material outflow. However, the star gradually regained its brightness over the following months, eventually returning to its normal magnitude. This led to widespread speculation about what had truly occurred with Betelgeuse. The prevailing theory suggests that Betelgeuse underwent an immense and unprecedented event known as a surface mass ejection, SME. This phenomenon bears similarities to coronal mass ejections, CMEs, observed on the Sun. To visualize an SME, imagine a volcanic eruption on a stellar scale. Material from the star's interior surged upwards and outwards, creating shockwaves within its atmosphere. Over time, this material formed molecules and dust, partially obstructing our view and causing the star to appear dimmer. In Betelgeuse's case, the SME involved the ejection of a mass approximately 400 billion times greater than what is typically observed during similar events on other stars or CMEs. This ejected mass was multiple times the mass of the Moon and was expelled at incredibly high speeds. Such a massive ejection from a star's surface had never been observed before. The event allowed astronomers to directly observe and examine surface details using the Hubble Space Telescope, offering a real-time glimpse into the aging and evolution of a dying star. The SME had a profound impact on Betelgeuse, causing it to lose a substantial amount of mass in a single event. This occurrence demonstrated that a dying star could experience significant mass loss beyond the usual annual decrease due to stellar wind. It was as though Betelgeuse had forcibly expelled its upper layers and was now in the process of slowly recovering from this injury. Following this dimming event, Betelgeuse's behavior underwent a noticeable change. Previously, it would pulsate or vary in brightness every 400 days. However, it is now pulsating every 200 days. Betelgeuse is classified as a semi-regular variable star, meaning it undergoes multiple cycles of fluctuating brightness due to variations in its size and temperature. This red supergiant is known to exhibit two primary periods of light pulsation, a 400-day cycle, believed to be caused by pulsations in the fundamental mode, and a longer cycle of approximately 5.6 years, the origin of which remains uncertain. In their research, scientists employed computer simulations to gain a deeper understanding of the events that transpired. They proposed that an unusually hot gas current, resembling a large and intense bubble, emerged from within the star. Such hot gas bubbles occasionally arise due to the star's turbulent and convective envelope, which can be likened to a pot of boiling soup where the material is constantly in motion and mixing. As this hot bubble ascended and broke through the star's surface, it triggered the ejection of stellar material. Interestingly, it also disrupted the star's regular pulsation pattern. The star's surface continued to expand while its deeper regions contracted, causing the transition from a 400-day pulsation cycle to a new 200-day pulsation cycle. Astronomers anticipate that the star's regular motions will gradually stabilize this unusual pulsation over the next 5 to 10 years, eventually restoring Betelgeuse to its typical 400-day cycle. Regarding the possibility of a Betelgeuse supernova, astronomers speculate that it could occur at any time within the next 10,000 to 100,000 years. Based on factors such as the star's color, brightness, size, and estimated age, scientists suggest that Betelgeuse is currently in the early stages of helium-to-carbon fusion. This process must continue through oxygen, silicon, and finally, iron before the star's core collapses under its own gravitational pull, leading to a supernova explosion. Since Betelgeuse is located 650 light-years away, any supernova event occurring now would only be visible to us after 650 years, due to the speed of light's limitations. Therefore, it is highly unlikely that we will witness the star's dramatic demise during our lifetimes. The unique aspect of Betelgeuse is that we can actually see its surface, which is a rarity among stars. This offers a remarkable opportunity to study how massive stars like Betelgeuse behave as they age, including such surprising mass ejection events. Recently, astronomers made a startling discovery. For the first time, they observed a star consuming its own planet, located 12,000 light-years away in the constellation Aquila. Betelgeuse, with its intriguing name and prominent position in the night sky, has fascinated humanity for centuries. Its significance extends beyond scientific knowledge, having left a lasting mark on pop culture and mythology around the world. The name Betelgeuse is derived from Arabic, initially interpreted as the armpit of the giant, though some scholars argue that it may represent a hand or shoulder instead. This anatomical association is reflected in various interpretations of Betelgeuse, often linked to anthropomorphic or animal figures. In different cultures and mythologies, Betelgeuse carries diverse meanings and symbolism. In ancient Japan, it represented a severed limb, while in Brazil, it was perceived as a turtle's leg or a caiman's hind leg. The Sanskrit term for Betelgeuse translates to the moist one, associated with the Hindu astrology's Ardra lunar house and the tempestuous storm god Rudra. Throughout history, Betelgeuse has played a significant role in cultural practices and traditions. For instance, in Macedonian tradition, it symbolized domesticated animals and agricultural life in villages. In other regions, such as North Baffin Island and the Melville Peninsula, its rising marked the onset of spring and longer days. Betelgeuse's cultural prominence is also tied to its position in the constellation Orion, where it is recognized as the star on Orion's right shoulder. As one of the brightest stars in the sky, ranking 11th in luminosity, Betelgeuse continues to captivate and inspire artists, writers, and filmmakers. Its ongoing transformation and potential for a future supernova make it a subject of immense interest and intrigue. There is so much more to explore and discuss about Betelgeuse, its recent changes, and the fascinating possibilities of its future. What are your thoughts on Betelgeuse's recent metamorphosis and the potential for a future supernova explosion? Feel free to share your insights and opinions in the